My initial idea was that soccer games could be predicted by their stats. It's going to be messy. Obviously, teams win sometimes when they shouldn't. We talked about that in the correlation video. But if something like Football Manager can take a series of individual player stats and predict game outcomes, then I figure I can do it too. So I've got all the stats they have available on the NWSL website. Not as many as you have from EPL, obviously, but they have most of the relevant ones, quite honestly. Shots, shots on goal. I wish they had possession percentage. They don't. Corner kicks is probably a good one. Corners themselves aren't predictive, but they sort of show how much pressure you're putting on the team. Offsides is probably meaningful as well, or potentially meaningful as well. I went with everything they had, quite frankly. There's not a lot of science that went into collecting these. It's just whatever was available. And that's, unfortunately, a state of women's soccer stats. On Twitter, at Woso Stats, I think is the account, is doing some great work cataloging individual games. It's a slow process, and I commend him or her, I'm not sure who it is, for doing it. But anyway, this is the games, and this is the individual game stats. I have a 90-something, and we can actually check that by doing dim games. That just shows the dimensions of this games data frame, and it's 93 by 18, so 18 variables, 93 games. Got those for all the games in last season's NWSL, including, it's 93 because it includes the semifinals and finals. We're going to load res in. Why I call it res, I don't remember. I called this my original script, and I've just never changed it. But what this is the results. That's why it's called res, apparently. Didn't take much thought. So this is the results of all the games. And we have, as you can see, I'm going to expand this a little bit, just so you can see it a little better. In the rows, we have the name of each team in the NWSL. And then the columns, we also have the names of each team in the NWSL. And what this is a matrix, and down the diagonal, NA. It's a matrix of the results between the two teams. In the EPL, it's a lot simpler because we have just one game between each team, and then they reverse them home and away. The rows, by the way, are the home team. The columns are the away team. I'll get into that a little bit later. But so this is when the Seattle Reign played the Chicago Red Stars at home, they won 0% of the points. When the Red Stars played Kansas City on the road, Red Stars at home, Kansas City on the road, they got 16% of the points. The NWSL has another weird thing going on where the teams don't, it's not like EPL where they do one home and one away fixture for each team. There's 20 games and only 10 teams, but each team has 9 opponents potentially. So some teams played each other twice at home, others didn't. I calculated this as a percentage of the total points you could possibly earn. So 4 was 100% of the points, 3 I think was 2/3 of the points, 2 was 50%, and I think 1 was maybe 1/3 of the points, actually, not 16%. I take that back. So yeah, 4 was 100%, 3 was half the points, actually. Sorry, shouldn't be. This is what I get for doing extemporaneously. 3 was half the points, 2 was third of the points, 1 was 16.67% of the points. Basically, the higher the number, the more points you earned against the team, the higher percentage. I had to recode them as 4, 3, 2, 1 because that's how the stats work. I'll get into in a minute. But this has basically the results for each home team and each away team in NWSL for the 2015 season. Simple is just a quick data set I did with goals for, goals against, goals difference, and the total points earned from a team over the course of a season. And we're going to use that a little bit later. It's basically the league table you'd see anywhere. Row names of that results file are going to be this first column here. So we're going to turn that into the row names just because I like having them there. Res $X, just to remind you if you didn't watch the last R video, means the X column of the res data set. So here's X, that's the column. We turn that into row names. So we move it outside the data set. Res, store res, comma, -1. What that does is it removes the first column from res. So I removed the column with the names, I moved it into the row names. We do this because when it wants to apply the math in a second, it's going to struggle with the strings here, the words. This next line, I'm going to run it, and it's going to do some processing while I talk. I'm storing something called results.tam, and it's a TAM MML mixed model. It's using the res data set. The IRT model is GPCM. The formula is going to be points by goal difference. So it's going to be the total points earned as a function of your goal difference. The data is going to be that simple. What does all this mean?